So good afternoon, everybody, and welcome to this online meeting on laser processes for automotive and electro mobility in cooperation with PhotonicsViews. My name is Antonio Castello. I'm Technology Manager at TechPeak in charge of all the laser-related members and topics, and it's a pleasure to be here to talk about this interesting topic that we addressed several times already in the past about what is new in laser processes. As you will see today in the agenda, we will talk about the different novel new developments. We will talk, of course, about beam shaping. That is one of the trends in this industry. We will talk about process monitoring, of course. We will talk about what is new in control of the beam characteristics and specifications. So it's going to be an interesting afternoon, and happy to have you here. Just a few words about the meeting today that is supported by the magazine PhotonicsViews. So thank you, Oliver, for cooperating with us in the organization of this meeting. They are also preparing a special issue about this topic, what is important in laser processes for automotive and mobility. I think, Oliver, you are connected, so perhaps you want to say a few words about this new issue, about what is PhotonicsViews as well.
Yeah, hi everyone. I hope you can hear me well.
Yeah, we can hear you, Oliver.
Actually, this special issue is already out since last week.
Okay.
I'm sharing the link in the chat.
Yes.
We have about almost a dozen articles about laser use for electric vehicle manufacturing, and yeah, I hope it's a worth read. It's a new format. It's an e-special format. That means that we can also include videos, so you can see the processes live as they are recorded. And yeah, we heard a lot of positive feedback for the new format, so I hope we will enjoy.
So thank you, Oliver, and thank you, PhotonicsViews, for collaborating with us in this meeting. And I hope it will be also useful for all the people checking this special issue. So what is else about the meeting? So what is else about EPIC? So this is a European Photonics Industry Consortium, is the largest industrial association in the world in photonics related topics. And our goal is to support all the members to find new collaborations, to learn about new markets, to find partners to solve the technological issue or the market requests. And this is a list of the benefits that we offer to all our members, more than 800 companies related with different photonics technologies. So we offer access to market reports, for example. We help with connection with investors, human resources activities. We discuss about technological needs, and we can connect companies to other companies that can solve their issues. And of course, networking is a very important part, as most of you know, of our activities. So we try to organize different meetings in topics that could be interesting for a lot of companies, so they can find new opportunities of collaboration or learn how they can access these new markets, and also discuss about what is new, what is happening in the future. And regarding these networking activities, we have in the future EPIC events. Of course, we continue with online meetings like this one with different technological discussions, but also my colleagues in the marketing team organize different meetings to discuss about or to help marketing departments in companies to take advantage of all the advices of experts in the field and improve the marketing activities. So the idea is to help all your departments. Also, in the next weeks, we will have some activities related with human resources and job opportunities. So we will have one online meeting about Discover Your Career in Photonics, also a human resources work group. That is one of the topics that we are discussing with the members, that a lot of companies are having troubles in finding people with the right expertise for them. So we try to help a little bit in discussing between the members and companies outside the consortium, how can we improve and the way to find people with the right expertise. And of course, due to the last news, we will have an online meeting about the impact of the US tariffs. So everybody's talking about that, as you know. So we'll have this activity in May the 9th to discuss internally about well, what is happening, how if somebody have advices of something to share about this topic. I encourage you to go to this link, to go to our website and check what is happening here in terms of online meetings. And of course, on-site epic events. We have different activities in different topics. So disruptive optic at Thales, for example, also display technologies in the display week in the US. And we will be, of course, active in Laser World of Photonics. So if you are going to be exhibitor there, please check the website and trying to join the activities that we will organize during that week. Of course, we will also talk about technology there. So we will have different tech watches and tech sessions. Two of them, one is focusing quantum, one is focusing in innovative optics. And of course, we will have also one in laser micromachining applications. So we will have a special 2-hour session on June the 26th to discuss about new developments, new opportunities, and we will have also the whole supply chain. So people that are integrators, users, and components manufacturers, laser source manufacturers, to discuss about new opportunities in laser micromachining, following the meeting that we had last year in Vilnius, quite successful in terms of discussion between all the companies there. And as I mentioned before, the recording, we will have this meeting focusing industrial laser processes hosted by Optoprim. So we organized the meeting in Italy, north of Italy, Milano, Monza area. It's going to be 10th and 11th of September 25. And are going to discuss about the laser processes for different markets. We have divided in sessions focusing automotive and mobility, aerospace and energy as well, one for semiconductor and consumer electronics, and one from jewelry, medical, a little bit of a mix of other industries that are also interesting for laser processes. So please check our website and see how the agenda is being built. And I will be very happy to if you can join us for the discussion in September in Italy. I'm going with the agenda for today. So as I mentioned, very interesting presentation. So we will start with a great presentation about Ecor International. We will learn what's happening with the laser in their facilities, also focusing automotive and e-mobility applications. And they are going to talk about also at the end the laser as a service digital platform that they are working on. So we will learn what's the plans in offering this service of the laser processes through digital platforms. As I mentioned, we will talk about beam shaping. So both Kylabs and Robust AO are going to present their proposals for beam shaping, in very interesting for all the laser processes, particular perhaps for laser welding in the battery manufacturing. We will talk about process monitoring. So thank you, Soren, from 4D Photonics as well, to talk about this interesting also well type of application for the laser processes. Marcus from Presitech will talk about the use of AI that is everywhere nowadays, and of course can help a lot laser processes. And we will finish with the relevance of laser beam diagnosis by Primes. So this is the agenda for today. Just a final word about all the companies that are joining us. So this slide with all the companies that registered for today. So I'm very happy to have a real good spread of different companies. So of course, lasers and equipment manufacturing is something that we expect in this kind of meetings. But I'm very happy also to have different end users and integrators that will work finally with the lasers and develop laser machines, integrating all the equipment and also the components and modules that you can see below. Of course, R&D is very important. A lot of our members are supported by R&D institutions in developing new applications, testing new solutions. So it's a very important support in the case of e-mobility applications. And then it's very important also to have software and design to help all the machine builders to develop their solutions, and you have a machine dedicated to one application. I'm very happy also to have other companies around, metrology and testing, materials, of course, and consultancy, service providers that can help end users also in some tasks that they cannot do on site, and then distribution and also journals and dissemination members. So that's all from my side here at the beginning. So I hope you will enjoy the discussion today. And it's a pleasure for me to introduce the first speakers. So as I mentioned, we'll have presentation by Ecor International Group. So we have Domenico Stocchi, that is R&I Director, and Rinaldo Rigon, the Technical Manager, and they are going to present all the activities at Ecor related with laser processes, in particular for automotive, and we will learn what's happening in this digital platform for laser as a service. So Domenico, the floor is yours. I think you will start, right?
Yeah, of course. Thank you very much, Antonio. Can you see my screen?
Yeah, we're waiting for the.
Okay, thank you very much.
Everything good. Thank you.
Good afternoon to everybody, and I'm really happy to join to this meeting and to have the possibility to share with you some of the news about the project, European project Laser from Us. And we are one of the partners of the project, and we are involved as technology and the user inside this project. I will I will present. I will show you the presentation, but please consider that Rinaldo is joining to the meeting, and also he is available for any question at the end of the presentation. Let's. So in the presentation, we wish we you we will show our point of view about the market penetration for laser welding technologies and our industrial approach, how different markets are integrated in terms of evolving needs of end users. From these sides, the needs of automotive manufacturing sector, let's say, are not so different from the ones for green energy or pharma or aerospace sectors, for example. And we will see also the key characteristics in business strategy from our side and how they are correlated to the growth both by a combination of products and technology and markets, including mobility. A quick picture about the Ecor International Group. Our sites are in the production manufacturing sites are in the north of Europe, and we are in Vicenza, 1 hour from Venice, 1 hour from Verona. We are 258 persons with a turnover of 55 million euro. Our business areas are the main one is in the food and packaging sector. We produce components and modules for automatic packaging machines, aerospace and defense, advanced mechanics and pharma, and industrial research. Our Ecor business model offer an integration of advanced technologies for welding and manufacturing, combined with competencies in the whole product design and development up to prototyping. The model, I think, represents a concept of full service where we can add value to support our customers, not only for what regards manufacturing, but also on product design to achieve a specific function on it. Here you can see our certifications, starting from the ones related to the system, to the process, and to the customer. As you can see, we are a company that has a great experience, let's say 40 years of experience in joining materials, or different type of materials, different type of components, and so on and so on. We have a NADCAP accreditation for welding, heat treatment, and NDT. The business areas, as I explained it before, are mainly 4. Here you can see the first 3 that are connected with the manufacturing of components. So we are a service company, so we do not have our products, but we produce products according to the specification, the requirements of our customers. Some examples just to understand what we produce and in the different fields, and in order to understand how we have a really diversified market where we are able to to supply different components with different qualities and so on and so on. So we start from single components up to subsystems, for instance, in the field of food packaging industry, rather than structural or other type of components like pipes for having different function in the field of aerospace and defense, and really a great diversification also in advanced mechanics and pharma sector. As I explained before, research and development for us is not only a cost, but a really a business area. For this reason, we have a research company that is dedicated only to industrial research, supporting for mainly the customer and only a little bit the Eco International. The turnover is eight or more or less 80 million euro for last year, and we have 56 persons dedicated to the industrial research. The competencies varies from 3D printing to functional design, surface engineering, metallurgy, welding, brazing technology, and so on and so on. All the plants that are dedicated to the industrial research are industrial plants, because we aim to supply to our customers high TRL results to be ready to be used for the specific aims that they require. Well, let's start to speak about market technology, and I would like to show you how the laser for mass process is a project that is really well integrated in the industrial area, how it aims to impact at the industrial level from the point of view of different markets, and also in the automotive or e-mobility sector. This is a brief picture about our business strategy, supported that can be useful to be considered by the Ansoff matrix. The matrix lie on 4 distinct growth strategies, each defined by a unique combination of products and markets, could be existing or new. So if we look at the market penetration, this means that we make leverage on the company's established strengths and market knowledge in order to increase the existing markets. An example could be the improvement of product quality or features to encourage repeated purchases. And from this point of view, the development or the introduction inside the company of innovative and advanced technologies can be for sure an answer to this first market penetration. But at the same time, we have also the market development. That means involving a strategy that involves existing products to be introduced in new markets or by different actions, considering, for instance, different customer segments. Product development is something that is correlated to what to the research business area, because it's something that is really connected in the investment in research and development for opportunities in innovation, the creation of new products according to our customer needs. It's important from this point of view, of course, the customer feedback and the collaboration with the key stakeholders. Last but not least, the diversification. This means we want to expand in new markets or new products that in some way are related to our business, existing business, allowing also potential synergies in terms of resources, capabilities, or customer specification. Here we go better in the field of the project, and we can understand how the concept of market consolidation and expansion in two fields that are actually preceded by us is pharma and, for instance, the field of fuel cell, where we already produce by laser technologies. Here we can see how we can move from these two markets where we aim to expand the business to reach another market that is a green field, that is the field of e-mobility. And this, the approach is to deploy the competencies and in terms of knowledge, in terms of technological experience, in terms of advanced technologies, and in terms also of another project partner already working in the automotive field. And all these experiences can be industrial experience and academic experience, and also other scientific and technical experience can be joined together to develop an integrated technology, manufacturing a service platform able to reach this specific target. We have seen the complexity of the parts that we produce. We have really a great number of geometries, a great number of part numbers, and the thickness of the sheets that we use to produce the different to manufacture the different components. We have different precision constraints and so on. Of course, all these variables impact on laser requirements. So the market needs, the end user needs, and the technology needs really has a different effect on what is necessary, what is required by the point of view of the end user for laser process and equipment. I would like to stress the fact that the main characteristics cannot be considered as alternatives or standalone because the laser technology needs to be considered as a whole set of features of modern advanced technology to be collected together. So easy configurability, reliable performance are mandatory for this field. Okay, now here you can see something that is correlated with the business and technological diversification through innovation. Diversification and innovation are essential for building resilience in times of economic uncertainty. We see every day there is something that introduces a new variable in the market. By exploring new markets, developing new products and services, partnering with other business, investing in R&D, or embracing new technology, the business can reduce the risk and increase the chance of long-term success. So technological diversification can help organization in mitigating this risk associated with relying heavily on a single technology or market. By spreading investment across multiple advanced technologies, company can reduce their vulnerability to disruption or shifts in customer preferences. Then, in today rapidly evolving business landscapes, enterprises face the dual challenge of maintaining competitiveness in existing markets while exploring ways for growth and expansion. Traditional strategies for diversification often rely on geographic expansions, for instance, or product line extension, mergers, acquisitions, and so on. But let's say that now in the digital area, a new paradigm can be considered emerged. Technology serves as a powerful enabler of diversification efforts. For this reason, Ecor, that is a service company, it does not have a specific product. We do not produce, as told you, a product that is designed by us. We produce on the specification of our customer. So what we can offer is really competencies and technologies to be competitive and penetrate new markets. In the real of the fact, these are our products, no? Because we can offer competencies and technologies. We need to practice continuous technological intelligence on the landscape of advanced technological innovation to maintain a competitive performance on a complex product, ensure high quality of these products, and also a sustainability of process product systems. The Laser for Mass process project represents really a fully collaborative approach from this point of view, with really transversal industrial objectives, aiming to bridge the gap between research and industrial practice. From our point of view, to adapt the changing market dynamics, the business should prioritize continuous learning and development. So inside the project, we think that we can find the suitable answers to these needs for our point of view. Okay, that's all. I thank you for the attention, and if there is any question, we are available for this.
Thank you very much, Domenico. So as he mentioned, we have time for questions. So feel free to raise your hand here online, and also use the chat to place a question. I will perhaps start with a question about, we were talking about laser welding. We will talk today also about beam shaping. I have a question about how mature do you think is the technology in your case? You have experience by servicing or producing components for your customers. How do you see the development in the last years? How mature do you think it is, the technology nowadays? How do you see the different approaches? So Domenico, I don't know if you have any comments about that.
Okay, start to answer, to give you an answer, but I'm really interested about also the answer from Rinaldo's side. I think that the technology is really a great technology that could impact on the market from this point of view, because it can allow really the manufacturing, by joining of different materials, can solve really different industrial problems that we face every day in our production. But it needs to be better specialized. It needs to be better investigated in order to find a great industrial interest from this point of view. The interest is really high in this moment. Also for us, we consider that the dynamic laser beam shaping is really a great technology that can have a strong impact from the point of view of the industrial production. But there are some topics, some issues that maybe need better investigated in order to finally resolve some doubts that can be found at the industrial level. Also, I have some discussion also with other guys in the field, and they say it's really interesting, but the cost, for instance, is a problem now for entering in the industry. So it's really important to demonstrate its industrial capabilities in order to allow to the industry to accept also the high cost of investment, in the technology. I don't know, Rinaldo, if you want to give also your point of view.
Yeah, I agree with you, Domenico. It's a new potential technology. We have to still to test it on the field, but looking at his main features in terms of high density of laser beam power and high speed available for the equipment, I think it will be interesting to test it during in the frame of the Lasers for Mass project.
I have also a question because Domenico showed a slide, I believe, a slide about requirements, let's say, from the also customer point of view. And one of the topics was high power lasers. Do you think, thinking in the sources manufacturers, that the offering in the market is nowadays enough? Do you expect a step forward in even higher powers in the type of components that you produce?
Let's say that, for instance, in laser for mass project, we are considering a 14 kilowatts power laser, and from the industrial point of view, this is really in the at the level of high power lasers. From our industrial point of view, we do not have such power lasers in our company, but generally is something that is not.
It's not more than 3 kilowatt.
Yeah,
Actually.
it's not something that is so diffused in the companies. But according to new scenario, according to also other application fields that can be in the, for instance, in the naval manufacturing production rather than in the defense and so on, there are applications that could be really affected by the needs of these high powers.
Okay, very good. I don't know if there is any other question or comment. Yeah, Alejandro.
Yeah, I do have a question. As a European service company, how do you see the development of the European and Asian markets, and how do you compete and differentiate against basically Asian similar service providers, in particular concerning a certain price pressure?
Well, let's say the first question, please, was.
I say two questions. How do you see that in your area? How do you see the development of the market within Europe and within Asia? And how do you compete and differentiate with Asian competitors in particular?
Okay. I think that there will be a really great growth possibilities for laser technologies in the market in different fields, because this is something that we are seeing not only in the automotive sector. For instance, if we think to everything that is connected to the concept of e-mobility, I think that it's easy to understand how laser technology can be deployed in that specific sector. But there are also other diversification markets where laser technology will find their interest, their applications, in order to improve the quality of the product, in order to have also a strong impact in terms of productivity, or in terms of having the possibility to produce new products that today cannot be manufactured by the available technology inside the companies. Regarding the second question, it's really a good question, I think, because today I think that in Europe there are great competencies. There is an industry having really the capability to produce and to produce high quality products. Maybe this the fact of quality, the reasons about also sustainability could be something that could have could represent a competitive factor towards the ASEAN area.
So thank you, Alejandro. I think
Thank you.
the question is answered. Any final question for Domenico or Rinaldo? If not, thank you again for being here this afternoon. Thank you very much for explaining also the laser for mass project, what is happening there. And yeah, we will be connected to discuss more in the future to see the next steps of the project. And
Thank you,
we
Antonio.
can, yeah, thank you, Ronaldo, Domenico. And we can continue this afternoon with the next presentation. So it's a pleasure to have Gwen Pallier, product line manager at the company Kylabs. So we are going to talk again about beam shaping. So a very attractive title is beam shaping, the key to become a world leader in battery manufacturing. So Gwen, the floor is yours.
Hello. Hi, everyone. Hi, Antonio. Can you hear me well?
I can hear you. We see the presentation like in this double slide mode.
Yeah.
Yeah.
So, like that should be good?
Yeah, now it's perfect.
Okay, wonderful. So thanks everyone for being here. It's my pleasure to participate to that EPIC meeting. It's been some time. I haven't done an EPIC meeting. I see it's still as active as it was some years ago. And thanks for inviting us to discuss about beam shaping and how we have actually demonstrated that there are some beam shaping options, modules, products that can be essential if you want to be a world leader in battery manufacturing and in e-mobility in general. So this is the outlook of what I want to discuss today. I will be quite quick on the first parts about Kylabs and beam shaping technologies and spend most of my time on the process results. And then I will shortly conclude with what we are developing and what we will be developing in the future. So Kylabs, in a few words, for those who don't know us, we are a company based in France. We are more than 130 now in the company, and this is our building in Rennes, in the west of France. And we are specialized in beam shaping from the beginning of the company. It was funded based on iodic technology, multiplane light conversion, which is then developed for a lot of different markets to address the potential of beam shaping. Along the way, we have actually identified that there are three main topics on which beam shaping is useful. Historically, we started with fiber networks, and we managed to improve a lot the data rate with beam shaping. Then, more or less simultaneously, about 5 years ago, we have opened two new applications. One is space communication, the product you see on the left. The idea is to communicate with satellites, typically all the Starlink satellites, with laser. Currently, it's done with radio frequency, and this is our biggest market right now at Kylabs. And we are also developing industrial laser processing, which is our second biggest market, and which we will be discussing today. So the idea with industrial laser processing is to actually provide turnkey and customized solution in order to improve laser processing. And I will get back to what means improve later on. So we have been working on a lot of different applications. And again, we try to focus on where we have the biggest impact. And we have currently identified that there are three topics on which beam shaping is really strategic for the further development of the application. It's welding, microprocessing, and additive manufacturing. So even though I'm quite happy to discuss about all those topics, I will be focused on welding for today. So beam shaping technologies. So you did say it already a few times, Antonio, even though it's only 337 here in France. Beam shaping is more and more discussed, and there are more and more beam shaping options. So let's try to shortly just review what means beam shaping. First of all, why we need beam shaping? Well, after working for a bit more than 6 years now at Kylabs, there is one thing that I'm sure of, is that it's nearly always possible to improve process with beam shaping. But you have to actually go through a certain thinking to find a good solution for your process. The first question is, what exactly do you want to improve? I insist a lot on that, but that will be a real part of my talk today. I want to insist on problems that the industry is having and that beam shaping can actually solve. So once you have identified a problem that you need to solve to improve your process, then you need to figure out what is the best shape to solve, to tackle that problem. Then when you have defined that the good shape to tackle that problem is whatever shape, let's say it's a triangular shape, what mean a good triangle versus a bad triangle? It's also very difficult, but it's quite important to identify what are the criteria which are important to improve your process. So typically, is it important that you don't have higher orders, or is it not so important? Is it important that your shape is actually really homogeneous, or is it not the main criteria? All those discussions have to be made at some point. Once you know what is a good shape and what makes a shape a good shape, you need to think about what is the best technology to do it. There are a lot of different technologies, and because the way the beam shaping is made, actually your capacity in terms of shape, but in terms of robustness and also in terms of price are extremely different. So then only you can identify what is the best technology for your process. And in the end, it all comes to, will it cost you more than what you are saving in terms of money? And even though I will not address that part today, it's for sure an essential question that everyone has to address at some point. The idea is obviously to help our customer to make money. It means either improve the quality. It's quite important to know that beam shaping can help for a lot of things that maybe are not so obvious as a start, like improving mechanical properties, process more complex parts. All that is possible with beam shaping. But I have to admit that most of the time we try to go faster, we try to improve the yield. It can mean actual more speed in the process, like welding faster, but it can also mean removing steps in the whole process, like removing pre or post-processing, which is having actually a huge impact in the end on the whole time of the manufacturing process. So as I said, there are a lot of beam shaping options in the world, more and more every year, actually. But I want to try to divide those types of shape into two big groups, the one which are inside the laser and the one which are outside the laser. And typically, I help you a little bit on mapping everyone. This is just, it's not covering the whole world, but I would say those are some big ones. You have multiple fibers, which are not all made the same way, but in the end, basically you can make a ring and a dot. Then you have current beam combining, which is in the end dynamic beam shaping, so it's a beam moving very fast. And then you have a lot of ways to do beam shaping which are not inside the laser. So in that case, you are more or less free to use whatever laser you are having, and you are implementing the beam shaping after the laser inside a module or inside a laser head. And all those technologies use different way to sync the system, but also way to manufacture it. And in the end, it gives different performances. I don't have time to discuss all technologies, unfortunately, today, but I'm quite happy to discuss it if you wish to reach me by email. And I will focus on explaining what we Labs are doing. That's what we were doing 10 years ago, multiplane light conversion. The idea is to do freeform beam shaping, any kind of shape, but we also managed to tune the phase profile. So it means that you have a shape which is having a plano phase in the process plane, which is extremely important if you want to have an extended depth of field. And we do that based on mode propagation, which is a system which is fully reflective. And what you see on the right is how it looks like when we develop products for laser processing. So it's implemented in between the laser and the process. It can be fibered or free space, and it's compatible with all lasers. I generally now like to say that I say there are so many technologies, like there are so many ways to make a laser, fiber laser, diode laser, disc laser. And after some years, it's been identified that some welding are best to do with some type of laser. I expect that one day the same will happen with beam shaping, and we will have a clear map of what beam shaping technology is best for what process. But this map doesn't exist yet. But just to say it, at least what Labs propose is compatible with all type of laser, monomode to diode lasers, CW to ultra short, and all wavelengths. And this is an apple on the left, a carrot on the right. So I was recently said that we shouldn't say apple and carrot, I should say apple and pears. Well, actually, we sell even something different in France, and we did not all agree on what vegetable I should compare when I say it in France. But one thing is sure, you have to be careful when you compare technologies, because the way they do the beam shaping is super different. So it's really not that easy to compare. So I will not say that I have a clear answer on how we should do it, but at least I want to stress the fact that it's not so easy to do it. Being said, so there are a lot of ways to do beam shaping. We have our own way at Labs. But why is actually beam shaping really a game changer if you want to be a world leader in e-mobility? Some process results. I will be going through a lot of different applications, and I don't want it to be a too technical presentation, so I will not be detailing all the process parameters and dimensions and setup and all that. So all my slides will be organized in that same way. You have an image of the process on the left, an image of the shape on the right, all the details about the process on the left, all the details about the shape on the right. I let you read, And even though I speak very fast, you are all reading faster than me. And I will then insist on why that shape can improve the process and why is it actually useful for the industry. First, we will start with some result that we have had with a ring dot shape that is implemented inside that module that you see on the right. That module is actually fully compatible with all Precitech laser head and equipment, and you can actually buy it from Precitech. So if you want to get some quotation from that module, you should rate Marcus, not me, because I'm not able to sell it to anyone else in Precitech actually from now on. So how it's implemented, you have the collimation, which is from Precitech and focusing, and in between you have a beam shaping module, which is made of 2 mirrors. And those 2 mirrors are actually doing the beam shaping. So why can we use that shape? So we have been actually trying to address all the biggest application of e-mobility and trying to see what the use of beam shaping for each of them. We started with hairpins, which is a quite classical application, which were made of copper. And in that case, actually, we wanted to focus on the spatters. Spatters are really critical when you do hairpin welding, because you don't want to have spatters going to another hairpin further, and in the end having shortcuts in your electrical circuits that can make the car burn or whatever terrible that could happen in that case. So we managed to demonstrate by just changing the beam shape from a standard shape to a ring and dot, we divided the spatters by a factor of 2. And this is actually super important if you want to increase or to reduce the scrap rate, to increase the yield of your manufacturing. We were also looking at bus bars. So we started with the motor, then the bus bar are connecting actually the motor to the battery. And in bus bar, it's also essential to apply beam shaping if you want to manage a higher gap. It's quite known also in e-mobility that you need a 0 gap welding. Well, it's not that true. It's possible to manage some gap, and beam shaping is really helping a lot when you want to do that. And if you apply the proper shape, you manage to actually increase the gap that can be accepted, and that gives compliant results by a factor of 1.5 compared to no beam shaping. And this is actually extremely important if you want to simplify the fixtures. Fixtures are complex and expensive and long to manufacture. So that's actually an excellent way to make your production more flexible and to make your production simpler. The motor, then the connection to the motor, then we go to the battery itself, so cell contacting. So in that case, we were working with the only battery module which we could communicate about, because most of the time it's super confidential. So that module is developed by Fraunhofer LT. And as you all know, it's quite, you have seen probably electric cars in the streets. So it's been existing for a long time, and there are ways to do this cell contacting, but the most common way to do it is to use what is called wobbling. So wobbling is doing a lot of little circle during the process. And I was quite strict with our partners, and I said, don't do wobbling. Whatever you do, don't do wobbling. We want to replace wobbling with beam shaping, and it works. And if you don't do this wobbling when you are doing the cell contacting, you can actually increase the speed by a factor of 5. That's, of course, excellent to increase your manufacturing yield. And again, regarding the bus bar, there was one last point that I wanted to stress, is that you can also weld deeper. If you have an extremely stable made pool at a fixed power, and I insist at a fixed power, because if you have more power, of course, it's easier, but you can slow down the process, which is super difficult, keep a stable keyhole, and manage to weld deeper. And in that case, we were managing to weld 3 mm over 3 mm at 8 kilowatt. Why is it so useful if you want to be a world leader? Well, it enables to have a more flexible production. With the same laser, 8 kilowatts, the same beam shaping module, you can adapt to a lot of different configuration, from not deep weld to deep weld of copper. It's working in any case, and it's extremely nice to have a flexible production. I will shortly mention some other application, because I think that it's good to talk a little bit about copper, because it's a classical topic of e-mobility, but we have actually worked on other parts of the vehicle as well. And in that case, we have developed a solution which is a hybrid laser arc welding with a ring shape and with an arc which is added to the laser head. This is the laser head with the connector, collimation, shaping mirrors, and focusing optics. And in that case, for now, we have been working on steel, but we will extend to other material in future. And the idea is, again, to manage higher gap. So it's definitely possible with a ring shape to increase the gap which is accepted when you are doing thick welding. So in that case, we were actually welding steel plates of 28 millimeter thickness, which is excellent actually to compete with arc welding. So it's very difficult to switch from arc to laser because of a process which is maybe a little bit more challenging, but it can also be more reliable and more efficient. But you need to have something which is very robust, and beam shaping enables that. And on a pretty similar application, we also demonstrated that you can increase the speed by a factor of 10 by using laser and arc together for that process, which is obviously very good for manufacturing capability. So I just want to say that there are a lot of other shapes that can solve a lot of other problems, like typically managing all the cracking issues in the complex aluminum, managing gaps in linear welding, a lot of different problems, and there will be a lot of more results in the future. So follow us and look at what we are developing. We are really trying to address a lot of different issues with our beam shaping solution. So this is just the beginning. We actually work on having systems compatible with more power. We want to have combined functions. We want to have dynamic system. It's already under development. We did it at R&D stage. We have to make a product out of that. We work on new wavelengths as well, complex shapes that are not possible with other beam shaping technologies. And we also work on new applications. So my conclusion now, I think that I did show it today. It's really possible to upscale laser welding with beam shaping. We are really providing solutions for a lot of issues of the industry. And I always insist people to think out of the box. There are a lot of possible shapes in the world, and it's not clear yet what shape is the best for what process. So keep bringing us problems, and we will try to keep bringing you solutions. And this is it for my presentation.
Thank you very much, Gwen. So we have time again for questions or comments. I can perhaps start with a epic question, Gwen. So you show what Labs can do for the others. Can you tell us a little bit what can the others do for you?
What can the others do for us? It's an excellent question, and I generally prepare it, and I haven't prepared it, but I know that we are definitely looking for a lot of components. So maybe I will stress on the one which are the most important for us. Currently, we are looking for people capable of doing good measurements. So we are in touch with Primus. I'm quite happy that they are also talking today. And I'm amazed by the work they are doing in actually trying to put metrics on measuring shade beam. It's super important in the future. And I'm happy to have more collaboration on that topic so that people stop comparing carrots and apples. So that would be quite excellent. And I know that in terms of components, we are always looking at people doing coatings, which can withstand high power and high energy, so high peak power. So we are also in touch with a lot of people, but I'm always happy to discuss with new people as well. And maybe people who are able to do fast switch. Again, Robusto is speaking next. We are actually looking at what they are doing. And if there are other fast switching capability, one way or the other, we are quite happy to look at how we could integrate that in our products. And of course, I'm also looking for customers, so don't hesitate to reach us.
Yeah. Very good. I have another question, and it's you mentioned that at the end, your beam shaping solution can work with any laser, but it's important for you the discussion with the laser manufacturer in advance to understand how can your components be integrated in the final system.
Yes and no. So it is essential because typically a system which is managing a femtosecond laser, if you put it in front of a CO2 laser, it's not working at all. So we need to know a little bit about the laser, but I would say that lasers which are quite close one to the other, they are anyway compatible with our beam shaping systems. So since there are big groups for different applications, I could say that typically when we developed a system for welding, well, it's working with most of the laser people are using when they do welding. Can it be Trumpf? Can it be Max Photonics? Can it be Rakers? Can it be IPG? Can it be something else? Can be Current. So they are in the end all quite similar. So it's quite compatible. And of course, we are happy if we can discuss with the laser manufacturer, but sometimes the laser manufacturers don't want to discuss with us, and we manage still to serve our customers without the discussion with the laser manufacturers in those cases.
Okay. So, well, that's can be a message that please, laser manufacturers should be perhaps a little bit more open to discussion with Kailas, for example. I don't know if there is any other question or comment in the audience. As I put it, you can use the raise your hand or use the chat for the comments. Well, if not, and if you are offering any of the components that were mentioned, please feel free to reach me, for example, if you want to introduce, or her directly if you want to discuss. Thank you, Gwen, for being here today, and we will be in touch for our future events in laser processes.
Awesome, thank you, Antonio.
Thank you very much. So we can move to our next speaker. So it's a pleasure to have here Soren Hollatz, is product manager for the Photonics, and with his presentation we are covering the process monitoring point of view. So Soren, the floor is yours.
Thank you very much for the kind introduction. I hope you can see my slides.
It's not in the full mode, but probably waiting. Yeah, now it's perfect.
Okay, thank you. So yeah, my name is Soren Hollatz. I'm working at 4D Photonics as a product manager, and I would like to talk about advanced process monitoring today with, in this case, focus on laser welding applications, because this is the most important part for us, and especially in automotive. So 4D Photonics is a small company located in Isernhagen, close to Hanover in Germany. This year we have our 30th anniversary, so join us at Laser World of Photonics to celebrate this with us. So laser processes and the process monitoring, therefore we have like two main goals that we are dealing with our products. First of all, we'd like to increase the process monitoring accuracy, because having pseudo faults or missed faults is very, very painful, and at the end very expensive in production. And the second goal is that we also like to classify the faults. So having a bad part is one thing, but having a bad part where you know this is the reason why it is bad, that helps you to adjust your production, to maintain your clamping devices or your safety window, let's say optics or whatever might cause this fault. And these are always our goals that we are offering the customer. Therefore, we have introduced a new product, and this is the 42 sensor system, and this whole system is called 4D Watcher. It is based on photodiodes, so we can coaxially integrate it into a laser head. Hope you can see my cursor now. So we can coaxially integrate it into the laser head and acquire the data that is coming from the process. So all kind of light emissions exposed by the process are going into our sensor system, and there we have a couple of different photodiodes catching the laser radiation, the visible range, and also the near-infrared range. And the special thing about this sensor is, and also the difference to our competitors, is the thing on the right side here. We are splitting up the near-infrared light and also the visible light into its spectral components, and have like 16 channels for each of these areas. And therefore we can acquire a lot of data to adjust the process monitoring individual to every process we would like to see. We usually do not need any kind of hardware filtering. We can just say, in this range, like in the red wavelength range, there is the light for our vision system. So we always have this red light from the lamps. And so we just leave these channels out of our monitoring without having any filter necessary there. With this sensor, we're trying to reach a lot of different markets, a lot of different applications. The idea is to have one sensor, one hardware for a lot of different applications, not just laser welding, also laser powder bed fusion, laser cladding. There might be also a picture of a brake disc here on the left. And also ultra short pulse processes and whatever you might think of. So for today, due to the limited time slot, I've brought two examples what we are right now doing, and there I focused on faults which are very difficult to identify with other sensor systems or in visual inspection in this case. The first one is gap detection. So Gwen also introduced that it's no issue with their laser to weld with a gap, but still it's an issue that happens there and which we like to avoid, or at least to detect, so we can decide if we can tolerate it or not. And this is a fault you usually can't see, especially when we're talking about battery welding with a couple of hundred battery cells in a module. You can't see if there is a gap under your bus bars. And there we did a lot of experiments with a couple of research institutes first, and then with a couple of companies. And this one is an exemplary data from an aluminum to aluminum overlap weld, like for prismatic battery cells. And here in the bottom, we can see like the result of one of the welds that have a gap inside. So in green, this is our reference band. So all of our reference welds are the signals of all of our reference welds are included in this green area. So this is more or less the area which is fine for us, which we are tolerating right now. And we are always comparing to these references. So reference is probably good process for us. And this black line here in the bottom, you can see that this one is a weld with a very, very small gap. And you can see that this black line is violating this red line, which is our lower limit for our process monitoring. And with this violation, our system would give you like an NOK result back for this weld. And you can decide whatever you have to do with this weld, if it's acceptable or not. It is actually not our responsibility. For us, it's just important that the system can see even small deviations that have an impact on our process. Another short example, Gwen has also introduced you the hairpin welding, welding of two copper pins. Here's one main issue that this process can lead to pores inside your hairpins. And this is also a fault type which is very difficult to see with different visual inspection methods or what else you can think of. And as long as you're not going to do a very expensive CT analysis, we might help you with our sensor system. So to make clear, we are not able to directly measure the gap or acquire the gap or measure kind of pore volumes. We can just give you a possibility based on the process. So the process is changing in some way, and we have to match it to the fault which is occurring in the end. So in this case, it's an example from real hairpin stators from a customer of us. I'm luckily allowed to show at least this graph. And there you can see again a green reference band, and also this black curve from our weld, which has at the end, they measured it with a CT, has a very, very high pore volume. And we can see here in the first steps, this black line is always more or less inside this green area. So it would have been a good weld until here, process step 4. And there we can see that the signal is going out completely out of our sensor limits. And at the end, the visual inspection said this pin is a good one. But due to the CT analysis, we know that there was a very, very high pore volume. And so we could identify the characteristics of these signals, which lead to a high pore volume. And this helps us to give them an idea which pins they have to double check or which pins are actually pretty bad, even if the surface looks good. Yeah, that is what we can do and what we can offer you, providing reliable multispectral process monitoring. I've said it also, we have one sensor for more or less any application that has some kind of light emission. And yeah, what you can do for us is we are always looking for new applications, for new laser processes. When there is a challenge for you in monitoring or with some failures in production, we are happy if we can at least try to help you and to prove that our sensor system is very capable of identifying these faults. Yeah, of course, also partners for scientific or industrial cooperation, ideas for future products or whatever is possible. We are open up for this one. And yeah, also that's one good thing at EPIC. There's a wide range of companies and also markets, and so that would be nice, of course, to have some new ideas for where we can use our sensor system. So that was a short overview from my side. If there are any questions, I have a lot of more slides, but we are limited in time, so I keep it with this one. Thank you very much.
Thank you very much, Sorin. So we have again time for questions. Claudia, please.
Hi, thank you for the talk. I have a question regarding in welding, the wobble technology is quite used, and I would like to know, is there kind of an interplay of this XY wobble technology to your sensor? I mean, does the signal change, and do you need to make new reference measurements in case one uses the wobble technology?
Yes, the signal definitely changes because when you're wobbling, if you have a circular wobble, for example, you're always hitting cold material in the front and warmer material in the back. So this is definitely affecting the signal. But usually it's not an issue that it won't work at all. You just have some kind of a sinus wave on your signal, and you're doing the reference process again for your wobbling process, and that's not an issue. Also, we're actually dealing right now with the idea to combine our sensor signals with the scanner data, so the scanner position data. And in our lab, it actually works pretty good. So at the end, we can have like an two-dimensional spatial path of your laser, and we can match our sensor signals to this one. So you can also see if you have some irregularities due to this wobbling.
Okay, thank you. And maybe another question, if I can.
Yep.
As you have, in case you have pores, the pores, they move. Also, in regards of the wobble technology, they are not static. It's like how I'm quite surprised that you can narrow down this movement and the pore size into just one value. Can you maybe comment on that as well?
Yes, the system is showing you some, giving you information about the process. So a lot of pores occur due to unstable process, keyhole dynamics, and these instabilities you can see with the signals. And identifying pores, for example, in happen welds, you need a lot of references to learn from, because we can't say your pore is 0.5 square millimeters in diameter. We just can give you a probability that in this process might have occur a pore or a lot of pores. There's not a, you can't say have a sharp edge between huge pore and very huge pore, or no, or yeah. So this is a difficulty for us, but in this case for the happens, it worked pretty much good that we could identify all the welds that have a higher pore volume out of tolerance.
Okay, thank you.
Any other questions for Soren? I have perhaps one question about the spectral range. The applications that you are seeing nowadays, do you see any need to expanding a little bit the spectral range more into the infrared? Or is something that for the moment you don't feel that is necessary in your product?
Yeah, actually, this is one of the topics on our research side, because if you're imagining having applications with polymers, you have the issue that the temperatures are very, very low. So the thermal radiation has a higher wavelength, and so you need to expand it a little bit in this direction. But it's not that easy, because there are also some limits due to some optics and the photodiode technologies that you can't go as far as you like to. So it's not that easy to do it, but we're still looking on it.
Okay, very good. Any final question for Soren? If not, thank you again for being here today. Nice presentation, and thank you for showing your developments in process monitoring. And we can move to our next speaker. So we are going to talk about the use of AI. So it's a pleasure to have again Markus Kogel. He's the head of department R&D projects at Precitech. So Markus, the floor is yours.
Yes, good morning here from Florida, and good afternoon to the Central European time. I hope everybody can understand me, and the video or the
Everything good.
Presentation is good. Yes, you did a great job over the years. I'm really, really happy to be part of that event here, and I was happy to be part of many of those webinars during the pandemic and even before. And you did select the order of the presentations really, really good, because you're a professional and you know how to set it up. Because I can a little bit go and rely on what has been said before. First, one slide for those who don't know Precitech. Maybe there are quite a few. We are still, let's say, a company who is trying to bring solutions to the market with respect to laser materials processing, which covers cutting and welding and additive. This is where we are active in the world. We have new partners like Innovasense from France. We are growing older. You see, Japan is already 25 years. The US will also shortly celebrate birthday. So yeah, and I'm part of that that group for about 30 years myself. But today let's talk about something which we call disruption. I know it has been discussed over the years if there have been some new innovations being implemented in industry, especially in our case in photonics industry. And these days, when at least I open my LinkedIn account, I might have, let's say, at least 40% of the posts somehow related to AI. And there are a few posts also related to beam shaping, because Caleb's is quite active and others who do beam shaping as well. But can we say we are on the way to a new disruption when we may just apply AI, or when we may combine few things? At least when we do AI, and this is what Precitech is doing now since about 5-6 years, we try to help the customer with respect to process monitoring. In that case, that we derive real physical information out of the process monitoring devices. I know we have a process monitoring device which is called OCT, and this is directly measuring penetration depths if you apply it correctly, and if the let's say the measuring range is in the penetration depth is in the measuring range of the OCT. Best regards to Bias and to Annika. We need to talk about that. But there are other physical information customers are looking for, especially in our cases when we talk about applications in automotive industry, and this is mostly where Precitech welding applications are applied. We're talking about the strength of the weld, or we are now, when we're talking about applications in e-mobility, we're talking about the electrical resistance. So is it possible to derive that information out of process monitoring? And that is why Precitech is getting digital, or has decided to get digital for some time now. We have a so-called incubator, which is a group of data scientists. They have their offices at the University of Karlsruhe. They're not part of Precitech headquarters. It's its own group, just data scientists, which just work with data. So they don't need necessarily to understand laser processing. They start to understand laser processing, I know, but they're also doing AI for Precitech sensor technology. So whenever we do a measuring in the context of consumer electronics, or in the context of semicon industry, we also start to apply AI on that data. But today I talk about the AI applications in e-mobility. And it's easier like that. Deep learning is easier like that, what you see here. This is one of the famous things which has been distributed all over the world, I would say, when it comes to AI and to the possibilities of AI, in that case, to distinguish muffins from dogs. And you might guess it's not that easy. It's easier when we do that in laser processing. We have done that when we started AI in applications where we did weld Taylor welded blanks, where we have camera technology on Taylor welded blanks, and where we can easily arrive a machine learning module on that camera images. And the previous one was a very, very complex image processing algorithm. And when you apply the correct and the nice AI tools, then you can much more shrink down the need for hardware, for calculation hardware. Nowadays, everything is done more or less also at Precitech on NVIDIA engines. So it's really, really fascinating how that everything shrink down, the computer hardware shrink down, the source code shrink down, in order now to be able to also process. That means in real time, get the error classes out of that. And doing that, for example, in Taylor welded blanks, we have a very, very high classification accuracy now. So when we go with pre-weights, we are already at 99%. So this is really, really fascinating how much we now can support customers' applications with a very, very accurate monitoring. But for sure, monitoring is not only camera-based. Typically, the applications are much more faster, and really extremely fast camera technology is also extremely expensive. That's why we are still working also with photodiodes. This is the so-called laser welding monitor, which is Precitech's invention since some years. And as I said, customers want real information coming out of that application. Mechanical strength, electrical resistance, leak-proofness, penetration depth. This is everything they are asking for. And we started to decide to work on that data, and we decided to go with AI. This is more or less, let's say, a little bit the little sister of the 4D2, I would say like that, because we are just working with three photodiodes and 3 wavelength areas from the visible range to the infrared, and we have the back reflected laser light. So it's not really that high sophisticated as a 42, but this is our tool with which we use to derive the AI. And as I said before, it's much more easy. And then I come to Gwen's presentation. It's much more easy to do that when the process is running smoothly, when you can overcome problems easily. And this is possible by the application of shape beams. This slide here I did present first time some years ago at a presentation at the AKL in Aachen. We are now at a point, and Gwen stressed that, or not stressed that, Gwen did elaborate on that quite nicely. We are now at a point where we start to really know which beam shape is affecting processes in which a positive way. And so we now have the possibility to have application-specific shapes at the workpiece surface to make processes much more forgiving. This you have seen before. Gwen has shown that. So it's what we as Precitech are happy to sell these days. So we have a contract with K-Labs where we can bring those fascinating MPLC modules into welding applications. Sometimes it's more than 2 mirrors, but typically we go with a 2-mirror one, which is here shown on the left. And yes, also one application from my side, which actually shows that shaping technology is compatible to the photodiode sensor technology. So this is what we did, or what the colleagues at Institut Maupertuis did together with a colleague of mine and together with K-Labs on an application which is somehow related to e-mobility, related to automotive these days. You see it's copper welding. And for those who have at least a little bit of experience on single traces on those welds, might actually see that the lower and upper limits of these welds are so tight to the resulting emissions. This is quite fascinating. And you see here some applications. We did run 50 welds. Everything, it's really, really, really smooth. You see it also on the cross sections. Sometimes you see a red light, which is indicating an error. So we cannot get rid of the errors. This is not meant because there are still influencing factors which we don't have in our hands. Contamination on the workpiece, let's say some irregularities in the materials, so you cannot have everything in your hand. Nevertheless, you see there are some ports actually which then also nicely be detected because the process is so smooth and it's so forgiving. And when we apply deep learning on those photodiodes, we go for a very, very, let's say, more or less old-fashioned deep net, which is called LSTM. A long short-term memory is also used by Siri and by Alexa. So it's especially made for data, time series data. Voice is a time series data. LWM traces are time series data. That's why we can easily apply that machine learning tool out of those many machine learning neural networks which are on the market. You see, this is just an overview of what possibilities you have to work on data. So we just picked out that one. You for sure have that presentation here afterwards available. So I will not read everything what is on the slides, but this is that machine learning tool, that neural network we apply mostly on our time series data. And yes, we can answer the question which came from the customer. Is it possible to map an input time series data to reveal value with a yes? So you see on the right, this is one of the applications which we did together with Audi. Audi was quite a good, let's say an excellent partner for bringing first time AI into automotive industry based on LWM single traces. So you see this is an aluminum application, and you might guess that we did a lot of applications, a lot of materials in the last years. You see it's always a number of test samples we need, samples to teach in, and a number of test samples, but the confidence factor here is with 95%. It's really, really amazing. And yes, so we can now predict physical properties like force, like gap, welding depth, or penetration, electrical resistance. We try to make it easy for the operator, and for sure, it really helps to identify the root cause. And you see these, if you compare the classical LWM to the LWM AI, you see that there is a lot of, let's say, advantages to go for AI. A lot of advantages to go for AI, and for sure, a lot of advantages to go for AI in combination with beam shaping. The more robust the process is, the easier the process monitoring is, the faster the AI is taught onto a specific process. This here is out of a video. I think you can find the video also in on YouTube. This is one of the applications we have also done together with Audi. Now it's on battery contacting, and you see we derive now the electrical resistance. And for sure, if the electrical resistance is not in line to the specifications of the customer, in the end, you see we have a full map of the battery module, and then, and this is quite nicely because we are working, we are not using, let's say, the full interface between the battery and the connector. We can derive a repair weld. We can derive a repair weld at the points where the battery, where the electrical resistance was not in line with the specifications, and then we can, at least with a high probability, bring out a full working battery pack for the customer. And yes, there's something which we may go if, let's say, the world starts to communicate again and it's not fighting against each other, then we maybe have the chance to work on an AI cloud, not, let's say, mostly only Precitech. Working together is important. We see that now in combination with K-Labs. We see that in other cases. Partnership is really important. And I can say at least combining AI and beam shaping, this is a clear yes to the question, is that a disruption for laser industry? It's a clear yes. And we don't want to see those processes anymore. So you see, it's spattering, it's a lot of what is happening. In the future, this is a spatter-free process because we apply beam shaping. So, Antonio, you may need to change your background image for the future because laser processes will be spatter-free processes in the future. Let's come to the final question. What can you do for them and what can they do for you? So you see our customer experience with the use of AI tools, especially in automotive sector, this is where we apply it. There will be a Porsche paper coming out soon where they show the combination of camera and photodiodes and getting even better results. But especially in the combination with robust processes, and this is only possible with the use of beam shaping, this is growing from week to week. And just to say that, we are happy. We are really happy to retrofit your application. So whenever you think your application might have some errors which can be overcome by beam shaping, and you want to also monitor the result, approach Precitech. We have your solution because we combine the process monitoring with the beam shaper, and this is the solution for every processes which are now a little bit running out of, let's say, out of borders. We bring your process into the best process window again by the combination of AI with beam shaping. And for sure, that's why we need more customers. So come call me, call my colleagues. And if you're open to new technologies, don't put brakes into innovation. And yes, I just remind you of the Superhero League. That was a great invention from Optoman, and Superhero League is growing and growing. You may have seen on Photonics West that Precitech joined the Superhero League with Sensei, the guardian of quality. So she is taking care of quality, and the Captain Shape is taking care of the right beam shape for your process. So Sensei and Captain Shape are your solution for the future of laser processing. Thank you very much.
Thank you very much, Marcus. Nice presentation. We have time again for questions or comments. I have perhaps a question about the data use at the beginning. Did you have any requirements in order to start the learning process in terms of the data you use? Now it's implemented in the head, so I guess you can receive all the information for the photodiodes and the camera. But how do you start the process? Do you select some specific cases?
No. We don't select cases. We have a template which we share with the customer, where we put in, let's say, all the required information. I can also share that template to you because I did present it, I think, also on one of the presentations before. So if we go a little bit more into the machine room of AI, you see that there's a little bit of preparation work needed before we start to collect the data. But no, we are still in a learning phase. For sure, we are still facing new applications, and that is why we just, let's say, agree on data formats. Let's put it like that: data formats which we can easily process and which we already have easily processed. Then, for sure, we go into the regression analysis, which means we will vary mostly every process input parameters, which may vary in your application, to see how the process monitoring data react on that varying process input parameters. And this is just a reply to Claudia's question to 4D. So we would also then, if there would be a Z module, we would also then modify the frequency of that and put that into our regression analysis and see how that fits to the AI module. But yes, this is what we need to do. We need to, let's say, vary process input parameters for our sample data. And then we do the test data, and mostly after that, the system is self-learning, hopefully.
Okay. Yep. Any other question or comment? Ciao, Domenico.
Yeah, I have a question for you, Marcus. I think that one of the obstacles in diffusing laser beam shaping technologies could be the difficulty in managing a so high number of variables to achieve a set of optimized parameters for each specific applications. I would like to have your point of view from this point of from this side. How do you think that AI tools could support in this specific task? Because an end user could be interested in introducing laser beam shaping technology in its company, but the question is how could be complicated then the management, the technical management of the full system once I have to find how to solve a specific applications if I have a great number of variables affecting the process, and if I have a tool that could help me in some way, well, the scenario can change.
So put it like that. I think when you have seen presentations from Gwen, she also talked about the cooperation of K-Labs with the TU Vienna and the Andreas Otto and his team. So this is where we start to work on varying beam shapes and to see how the process reacts to that variation. It's much cheaper. It's much cheaper to do that in a simulation than to do that at a laboratory or even at a customer site. So out of that simulations, we know the best beam shape. And customers in their specific application don't want to have any process input parameter variations for their process. So we will, in the end, have the best beam shape for specific applications. There is no doubt about that. We have the best beam shape for the specific application. For sure, we are still learning together with K-Labs, together with the scientific partners. For example, if we just talk about ring and spot, what is the best distribution with respect to the power ratios? This differs from material to material. This differs also from the thickness of materials, even though it's maybe just aluminum. But in the end, we will be able to provide our knowledge, a template more or less, which just shows where you can select, okay, this is my laser power, this is my material, and in the end, you come to the best beam shape for your application. And the Andreas Otto and the simulation guys, and for sure then the next step, which will be proving that in reality, mostly this is done in combination with X-ray analysis, real-time X-ray, together with IFSW or other Fraunhofer IoT, to show really the in-depth process, how it's getting pore free and whatever happens, and also the material flow and everything. So yes, there will be in the end a possibility to provide the best shape, and for sure Andreas Otto is using AI to do that. And I see Gwen also raised her hand. I think she has a comment on that as well.
Yes, please, Gwen.
Yeah, well, Marcus did say a lot, so I will not repeat what he just said, but I, of course, fully agree. Just to say, I discussed what is the AI roadmap of Professor Otto, which I strongly advise anyone not following him to follow him, because he is actually doing a really great job with his team, because he has actually a great team with him. So they say that the first step they want to use AI for is image analysis. Actually, when you do simulation, it's excellent to try new steps, new shapes, new process, etc. And for sure, it's much faster and much simpler than doing the process itself. But it's very difficult to recognize in the shape what is the depth, etc. So they could use AI. Actually, Fraunhofer IoT is also working on that to analyze the image and get data from those images. Second step is actually to extrapolate data in between simulations. So every simulation is taking a lot of time because it's complex simulation, and you want to do just a few of them. And if you are somewhere in between, you extrapolate with AI. Currently, it's not done, so it's something they are working on. The next step is they want to have a physics-based AI algorithm. So it means that right now they use some equations, which are more or less based on physics analysis, more or less based just on data analysis and trying to find a model that fits with the data. And they expect that AI will figure out new equations to solve all those physical problems. And the last step, but honestly, I think they are quite far from that, is they call it solving the inverse problem, meaning that you don't put a shape and you get a process results, but you say, I want that process result and I get that shape, which is exactly what Marcus was saying. So actually, AI definitely is really part of the simulation part, and that's probably the core of the use of AI right now, even though some people are using AI actually to create, typically Fraunhofer IoT, again, they are making MPLC-like systems, the team of Paul Busco and Carlo Holly, and they use AI for that. But I would say, for now, it's a new way to do calculations, which were done another way in the past. The real revolution is on the simulation, for sure, also, in my opinion.
Great. So thank you, Gwen, for the contribution as well to the question of Domenico. I think the question is more or less answered, right, Domenico?
Yes, thank you very much.
Thank you very much. So thank you, and also Marcus, for a nice presentation and for giving us some input to think about the future as well. We can move to our next speaker. So we continue talking about beam shaping, in this case, dynamic beam shaping, and how it works with high-speed, high-quality stainless steel laser cutting. So we have Claudia Reinling as the founder and managing director of the company Robust.io. So Claudia, the floor is yours.
Thank you, Antonio, for the introduction. That's my first time with this EPIC format, and I'm quite happy about it that I'm allowed to join this. So I'm Claudia, I'm the CEO and founder of Robust.io, and today I would like to introduce a new dimension in laser cutting called dynamic beam shaping for high-speed, high-quality stainless steel laser cutting. I would like to start with a few words about the company. Well, the name of the company is Robust.io, and it means we do robust adaptive optics. So we are really a pioneer in the industrialization of high power adaptive optics. So to narrow it down, we do deformable mirrors for high power applications. We have a small team now, 8 people, but we are very experienced in the fields of designing deformable mirrors and controlling them very fast, and also in the application development. And last but not least, the company Robust.io is a spin-off of Fraunhofer here in Jena. The motivation for all this dynamic beam shaping is shown here in this picture. Normally in laser cutting, the cutting speed is mostly driven by the power or the brightness of the laser source. So the more power you have, the faster you can cut. And we were curious about dynamic beam shaping so that we can add another dimension to improve the cutting process, and we mainly focus on the cut quality without losing the processing speed. And the tool that we developed is dynamic axial beam shaping. So this means, I show you the concept here. We have a laser focus, as you all know, and we focus and refocus the light very quickly along the oscillation or along the thickness of the material and the propagation of the beam. And in general, we have three parameters. We have the oscillation amplitude, we have the oscillation frequency, and we have the oscillation offset. And the next picture shows you how the oscillation amplitude can shape the beam. So the oscillation amplitude in the end controls the width and the intensity distribution. So if you compare what is feasible, a static beam and a dynamic beam shaping beam, axial one, then you can broaden the spot diameter up to 250%, and you can increase or stretch the Rayleigh length by a factor of 12. And if you do this, like it's shown in this picture, you can see that the intensity, the energy, does not drop down too much on the rim, but is very constant on the very long shape. And this is really the trick of dynamic axial beam shaping. And the other degrees of freedom is the overlap. And I show you here two possibilities. So the overlap is tailored by the feed rate and by the oscillation frequency. And if you have a very low overlap, like minus 250%, then you can see that the beam is traveling like in a zigzag way. And if you have an overlap of 50% and above, then you have a constant energy distribution along the feed direction. So to sum it up, what do we do? Robust.io, we develop hardware that rethinks adaptive optics technology. And the product that we're doing is the Swabble technology. Swabble because we wobble in the Z direction, and it's a deformable mirror. It has a very thin mirror membrane here in yellow, and we have a piezoelectric actuator that acts on that membrane. And we have a sensor, because if you use piezoelectrics, it's quite fast, but you also have hysteresis and nonlinearities. And we want to have an absolute position feedback. That's why we're using the sensor. It is implemented in a standard cutting head as a 90-degree deflection, and it produces almost ideal biconic mirror deformation at the highest speed. To give you some numbers, the maximum oscillation frequency that we have now is 3,500 Hertz. And the minimal step response between minima and maxima deflection is below 2 milliseconds. So we are quite fast. This is our first USP. And the second one is that we are we like to work with high power lasers. So our actual limit is 20 kilowatt. That's because we were not able to test it with higher laser loads. And what we already showed up to now is that we have loads of quality improvements regarding edge roughness and loss. We have larger process windows, like higher nozzle distances, and of course we have higher cutting speeds. But now I go a little bit more into detail. And I would like to start with one of our latest results in the terms of fusion cutting of stainless steel. and we have here the results of the cutting speed over the laser power, and we compare our technique with the static focus that you probably all know. And you can see that the actual DBS is on all power levels faster than the quality cut of static focus. And in the low power of 8 kilowatt, we are more than 80% faster. And in the high power of 20 kilowatt, we are 37% faster, which is equivalent to 5 kilowatt laser power. And on the right-hand side, you see some details on the quality. So what we can see with the static focus, that the quality remains more or less constant with an average burr of like 200 micrometer. And with our technology, we can improve the burr at least by a factor of 2. And the most impressive results are with the maximum power of 20 kilowatt. So we achieved the highest speed and the best quality at 20 kilowatt. And here's the one-by-one result. In the upper picture, you see the static focus, which already has a really nice quality and low burr. And here on the lower side, you see our results with a better quality in times of burr, which is really, really little absent nano burr, how you would ever call it, at the high speed that is known for the separation cuts. And if you go a little bit more into detail, beside the dross reduction and the faster cutting, we also have a significant reduction of the roughness by, let's put it like by a factor of 2. So these results were all in the same sweet spot, so we don't have a difference between separation and quality cut. It's all the same in our case. This is another example in stainless steel, also a thickness of 10 millimeter, but with lower power. And this was a bevel cut. And you see also that we could reduce the burr to very, very little values, and we could also reduce the roughness of the cut. And the last example that I bring, again stainless steel, but a thinner stainless steel of just 5 millimeter, and we compare ourselves again to a very nice result with a static spot, and also with very, very little burr. And we could have, with our technology, we could more than double the speed and keep the nice quality. And what we also experienced is that the process is more tolerant to nozzle distance changes. So it's a more robust process if you compare it to a static spot. And finally, I would like to show you some results for the systems integration. So we made the integration into robot arms. If you have just low power, which is accessible by robot arms, if you have the beam inside the robot, it's available in a laser form machine for fine cutting. And it has also been tested in a Nukon machine for 6-sheet cutting up to 20 kilowatt. So to sum it up, we focus on quality improvements without losing speed. So we provide quality cuts at separation cut speed. We show that we can really reduce nano burr in stainless steel. So our goal is always to remove any post-processing, but that you can take the part out of the machine and use it. And our current upper limit in laser power is 20 kilowatt. So if you have any 30 kilowatt laser and above, we would be happy to test it. And what can we do for you? So if you have any issues in cut quality in metal or also glass, independent of the wavelengths of your machining laser, please let us know. Any need in super fast light focusing. And we would also be interested to spread our experiments a little bit more into welding applications. So what can you do for us is if you have any issues in quality or would like to test the technology, then please let us know and we would be happy to help you. Yeah, so thank you very much, and I'm open for questions.
Thank you very much, Claudia. So we have again time for questions or comments. I will perhaps would like to know, as you are using an adaptive optics approach, do you need something related any component previous to your system to do something with the beam, or you can use a standard laser head to introduce then your system inside?
Okay, so we, in general, we can use standard laser heads. We have been working with almost single mode lasers and multi-mode lasers. The only thing is that we designed our mirror as a 90-degree deflection mirror. So if you go really to high power applications, we would need 2 mirrors in order to make sure that the laser still comes from the top, what is normally the intention. But beside that, we don't need any particular like plates or whatever. I mean, also the system is quite non-sensitive to changes in the diameter. Like we can work with 10 millimeter, 15 or 20. It's always the same mirror. Yeah, so it's we don't have hard restrictions here.
Well, what about in wavelengths? Do you have different solutions depending if it's infrared or visible laser?
Yeah, our standard like working horse is between 1020 and 1080 nanometer, but it works also for 980. But we have also mirrors for UV, like for electronics industry.
Yeah.
We have a mirror now that has been set up for 2 micrometer. So this is also a new wavelengths in cutting, welding, and so on. So we can also go in this direction. And we have one for 10 microns, but to be honest, it's there are not many people that still would like to be innovative with 10 micrometer.
Okay, yeah. Very good.
Yeah, but we have just a glass mirror, so if you have any wavelengths I did not mention, you can be sure that we can work with this.
Very good. Very good. I don't know if there is any final questions for Claudia. If not, thank you again for the presentation. Thank you for being here this afternoon, Claudia, and also for showing us your approach to the dynamic shaping. And I see that Christoph is already sharing, so he's our last speaker this afternoon. Head of sales and marketing at the company, Primes, and he's going to talk about laser beam diagnosis. So the floor is yours.
Thank you very much, Antonio. I hope everyone can hear me, but I guess so. So first of all, thank you very much to all of those who are still in the seminar this afternoon. I'm happy to present on my topic, the relevance of laser beam diagnostics in battery cell manufacturing. So my topic will be slightly based on beam shaping as well. So we have heard about that several times today. It will be also part of my topic today, because there is a certain relevance. So skip the slide. So first of all, what we at Primes do. So we are developing and producing systems for the characterization of industrially employed laser beams as used in, for example, the automotive industry. We're still an independent and completely owner-operator player with now more than 140 employees, most of which are located in our headquarters in Pfungstadt, so in the Rhine-Main region, and a few colleagues in our subsidiary in Yokohama, Japan. So what we offer more than 30 years of experience in improving laser-based processes. So our portfolio ranges from laser power measurement and devices for characterizing the propagation of laser beams to integrated all-in-one solutions. We offer solutions for laser manufacturers through to the end users. And what we look for, so we're always looking for challenges. So challenges such as programming suitable software to answer all imaginable questions related to performance of lasers. So it's our laser diagnostic software. So why using lasers in welding? So others other presentations might have answered this fundamental question already, but we often have a slightly different view of this process. So for example, precision. So laser welding is the method of choice for applications requiring a high degree of precision. Because of the low heat input, laser technology is the best method to weld highly sensitive components. And last but not least, the efficiency. The production of lithium-ion batteries is a very complex and sensitive process that involves very high material and energy costs. For this reason, the manufacturing process must be very efficient with high batch numbers at low cost. In order to take advantage of these benefits, it is crucial to check the laser performance in detail, not only at the manufacturer, but also during production. The advantages only become apparent when you know your laser. So skipping slides is still a little bit delayed. So I would now like to give 3 different examples of lasers used in welding applications. We will start with multi-mode, continue with single mode, and later on combine those 2 in core and ring assembly. First of all, I would like to point out a series of measurements for which we measured a whole series of machines. So all equipped with the same laser and used for the same purpose. We have performed direct fiber measurements of multi-mode lasers starting at 100 watt up to max power of 5 kilowatt. And as the fiber fills up with light, the calculated parameters change. So in this case, the direct fiber measurement means that there was no additional optic involved. So it was like the outgoing inspection at the laser manufacturer site. So therefore, this test is normally performed at the laser manufacturer, but we do that sometimes as an incoming inspection at our customer site as well. But for the following graph, so there it is. For the following graph on data cloud, we will now concentrate on power levels above 2 kilowatts. So we got rid of the 100 watt measurements. So even though we are now concentrating only on the power levels used for processing the material, the variation is very large and many data points are slightly outside the value specified in the data sheet. Each blue dot represents a full caustic measurement at 1 out of like 100 plus laser sources that have been characterized during this process. If you now take the additional influence of the processing head into account, you can see that things cannot get any better. Variations in quality or in the alignment. So in the alignment, like pollutions intensify this effect. So pollution, it could be like this, or shown on the image you can see right in the center of the slide. It can just be a dip in the power density distribution of the measured beam. This image is taken around +2 radar lengths outside of focus because pollutions somewhere around the optical elements will not necessarily appear directly in focus, but typically out of focus. But it's not just the change in the beam distribution at this specific position in the beam path. It will most likely affect the thermal behavior of this laser. So it does make sense to measure that. The second example uses a single mode, so displayed in red, instead of a multi-mode laser. The advantages are quite obvious. So you can focus the laser down to a smaller spot and therefore achieve the same power densities at lower power and maintain the same radar lengths or the same working area in Z. So due to the use of longer focal lengths, you can process faster on even bigger areas. So there are even more benefits you can have with single mode lasers, but just to mention a few of them. But where there is light, there must be shadow as well. So the single mode lasers tend to develop astigmatism more quickly, like shown on the upper right side. It tends to cause higher degree of thermal lensing. On the lower right side, there is a graph coming from our software that just shows the shift of the focus position over a batch of welds that has been performed on a battery, for example. So it has been taken offline, but that is how the spot or the focus position can shift from weld to weld if you don't control that. And last but not least, more sensitive to alignment and the quality of optical components. So what we do see quite often in the field is that spot die or spot in focus are still quite round, but different kind of effects might appear around the focus. But one or two radar lengths outside of focus, you can see that in this specific example, I guess that the quality of the optics used, probably the collimation lens, was not probably chosen for this kind of laser. So different effects appear, which will result in changes over time or so. So let's jump into the next example and combine the best out of two worlds and have a look at structured or adjustable ring lasers. So conventional analytics, according to the ISO 11146 standards, using, for example, the second moment method, yield the focus position and the radar length. They are meant to do that on single round spots. In this example, we see that the structure of the beam is lost within less than one radar length. Therefore, we decided to define a further set of parameters for the analysis of ring beams. The structure focus is defined as the position with the smallest ring width, and the structure depth is the distance at which the width increases by a factor of square root out of 2. So we use the conventional definition of the radar length, so an increase in the area of the square root out of 2, but we apply it to the ring. So to obtain these values, we take cross-sectional profiles of the beam at several angles. So like shown in the lower right corner of the image. So furthermore, we can analyze the beam shape in terms of power distribution. In our example, you can see a distribution that has been generated using a DOE. So I just want to point out that in this specific case, 14% of the power is not within the main structure. So it's not guided in the core and not guided in the ring. This effect will not be present when using the cladding of a fiber to produce this kind of ring shape, and it can vary a lot. So you can see smaller numbers, bigger numbers, but it does obviously make sense to check for the power that is not within the distribution that is meant to be used for processing the material. So there will be other parameters that can be used to compare those lasers. At the moment, it is quite obvious that the standard methods will make a comparison impossible. So like mentioned by Gwen, it is like comparing apples with carrots. But that is exactly where we want to start. We want to make lasers comparable. So that is our challenge. So not only in my presentation, shaped laser beams have constantly been present, not only round and sometimes timely shaped, but finally, I would just like to point out that we can measure them all, almost. So I would like to close this talk with the two questions that came up in every single presentation. So what can we do for you? So we can make your laser beam comparable, that is one hand, and what you can do for me. So we need to set more sets of data as well as your experience to further improve our algorithms. So we have done a lot of work on measuring structured beams. It can be, it is not limited to round beams. It can be any kind of beam shape. But without knowing the interaction between the laser and material and what is important about the structure that is measured, you can generate analytics to put numbers on that, but at the end that doesn't make any sense. So thank you for your attention and happy measuring. Thank you.
Thank you very much, Christoph. Very interesting presentation. we have time for questions or comments. I have one question regarding the influence of the material in the actual energy distribution. That can be a little bit different when using the same laser with the same shape, let's say. Is something that you have in mind also to introduce the effect of the material? Is something that you do already, or how do you approach this potential difference?
That is not that easy to answer because we always try to be independent. So we are not trying to make the work of others. We're just trying to compare different kinds of shaped beams, for instance, that can be can have been produced from a laser, that can come from a DOE, it can be a K-labs. It is completely independent of the actual application at the end. So you could use so to point out Pretotech, for instance, and the coax printer. So the coax printer itself is using a ring-shaped laser. It has got nothing to do with or the proposal is different compared to other applications where ring-shaped lasers are used. And therefore, we don't want to get into too much detail about the process itself, but we want to make the beam completely independent of the process comparable.
Good. And I have a question also regarding the integration of your system in a machine at the end. We have some companies doing machines for laser processes in the room. So any comment about your integration of your solution? What do you need from them in terms of ensuring the proper working process?
Yeah. So at the end, we're trying to serve everyone in between the laser manufacturers and the end users. So putting the right numbers on different parameters, it can be of interest for those just buying lasers and trying to buy different kinds of lasers for the same purpose. But it can also be, our customers are also integrating our solutions into their machines to, from time to time, check the parameters. So it can be just power measurement integrated in the production line, but it can also be a camera-based system like the focus parameter monitor to check the actual performance of the laser from so like every end part, for instance. So these solutions are not yet integratable into the head, but are still like an offline tool to check from time to time.
Yeah, very good. I don't know if there is any final question for Christoph. Well, if not, thank you again, and thank you for being the last one in the meeting today. That is always a difficult task. So we are launching now the poll, so we appreciate if you can answer, so it will help us to be more effective in our next meetings. And I would like to say thank you to everybody for being here today, for the nice discussion, and thank you to all our speakers, Christoph, Claudia, Marcus, Soren, Gwen, and Domenico and Rinaldo. Thank you for all the presentations and, as I mentioned, the discussion. And I would like to finish today just with just refreshing the meeting that we will have in the north of Italy in Autoprim. So I hope that I can see you there. So again, we will be in Italy in September 11th, 10th and 11th, sorry, of September, in the Milano Monza area. So I hope I will see you there, and it was a pleasure to moderate the meeting today. So thank you again, everybody, and I hope you will have a good afternoon. Thank you.
Thank you. Thank you, Antonio. Bye, everybody.
Thank you.
Bye-bye.
Bye-bye.
Everybody.
Bye, everyone.
Thank you. Bye-bye.